In the previous video, we worked through a common scenario for building a custom image. In this video, we're going to look at scenario 2, creating a custom image from scratch. Well, it's not really from scratch. You always have a base image to start from. Most of the bases are really just stripped down Linux images. We have images for Alpine, Debian, Ubuntu, and so on. From these bases, we can do whatever we want. So let's try that out. To follow along with this video, you will need your running K3s cluster, working Docker registry, and Docker installed on your development PC. For an example, let's build a backend service API using Node.js. Again, I've pre-made an image for us to use. Let's go get it. In case you're wondering, this is an incredibly useful service that, upon request, serves up quotes from a now quite old movie. We know we're going to be building an ARM image, so let's go ahead and copy over that magical ARM emulator for use in our Dockerfile so we don't forget it. I provided 2 Docker files in this repository. So Node actually has its own base image that we really should use if we're going to do something like this. You can see how that would work by reading dockerfile.recommended. However, in order to demonstrate the process of really creating something from scratch, we're going to use a more manual method. This method is already provided in Dockerfile manual, but let's go ahead and build a Dockerfile from scratch to better show the thought process that goes into it. So if we think about what steps we would do to build a custom Linux box to run whatever it is that we want to run, those are basically the same steps we do in a Docker file. Once the Docker file is written, we built it into an image, and we can reuse that image anytime that we need that software. We could also use that image as a base for building new images. So if we stub out Dockerfile with some comments, we want to start with a base. We want to install Node manually. We want to copy in our custom code, which is really our service. We want to build our service code in the image itself. And then finally, we want to specify the command to run when the image is started. Let's fill these in one by one. We'll start with a base. Let's use Debian Buster Slim, as it's a bit smaller than the standard Debian. And we'll copy in our emulator. Now we're going to install Node using the Node version manager NVM. The steps required to install Node are specific to Node and NVM. Obviously, if you were installing something else, you'd have your own set of specific steps for installation. In NVM's case, we need a bash login shell because NVM stores some environment variables that it needs to run in .bash rc. This shell command lets us set that up. Next, we'll install some utilities we need using apt, just like we would on a real Debian box. In the case of Node, we need wget and we need libatomic1. The rm command, that just cleans up the list that apt-get update creates, since we don't really want them hanging out, taking up space in our image. Next, we use wget to download and install NVM. Now this is taken directly from NVM's installation instructions. And then finally, we use NVM to install Node 12, or Erbium. Now we use the copy command to copy our source into the directory /apt in the image. Now this directory is arbitrary. I made it up. Then we say workdir to /apt. This means that the rest of the run commands and the command will be invoked in that directory. Now we invoke npm-ci to install the Node packages that our service needs. With the cmd command, we specify the command that will be executed when we invoke the image. Okay, that's all done. We can save the file and exit. Now we can build an image. Now this may take a bit. It's going to download our base Debian image. It's going to execute all those run commands to install stuff. It's going to copy over our application code. and then install its needed node packages. Now that it's done, because we use the emulator image, we can test this out locally. We can see the message PB quotes being served in port 1987. So now if we invoke curl in another terminal, we should get a quote back. And there's our quote. Great. So now we can kill the container by pressing Control-C in its terminal. And we're ready to push this image up to our Docker registry. Okay, the image is in the registry, and we just need to deploy it. Now I've pre-created the YAML file, bride.yaml, so let's take a look at it. So if we just look at the important parts, we can see the image is set to what we just pushed, and the container port is set to 1987. Also, we have our image pull secrets entry set so that Kubernetes can authenticate with our registry to be able to pull the image. Now you may notice that there's no ingress section. Typically you want to expose backend services to the outside world. Instead, they will be used by other services inside your cluster. So Kubernetes makes this easy to do, and we're going to explore how to do that in just a moment. Because we want to try this out from our development PC, we will make a concession for convenience and specify a service type of NodePort. We save the file and do our standard deploy. Let's give that some time to spin up, and then we'll check and see if it's running. Okay, it's still container creating for me. We'll give it a little more time. And check again. Let's take a look at the services table to see what this NodePort thing is. So we can see our services type NodePort, and it has port 1987 mapped to a node port of 32419. So what this does is opens up that 32419 port on all of our nodes. So we can connect to any node in our cluster on that port, and it'll get routed to our service. Just so that's clear, this routing is done by Kubernetes. Traffic has no knowledge of this service since we didn't ingress it. So this is all Kubernetes. So to see this in action, we can use curl to hit all of our nodes, and we should get a quote back from wherever we go. We'll hit kmaster. We'll hit knode1. And we'll hit knode2. So no matter which node we connect to, we get routed to our service, and we get back a quote. So that's cool for testing and some manual things we may want to do from our PC. But what if we had another pod that wanted to use our backend service? It's incredibly simple. Kubernetes maintains an internal DNS, so we just reference our service by its name and service port. That's it. Let's try that by spinning up a quick BusyBox pod running on the cluster that we can interact with. So this is a pod that's now running inside the cluster that we've just shelled into. From inside the pod, we can use wget to grab quotes from our service just by using its name and service port. Pretty easy. So to exit, we just hit Control-D or type exit, and that pod will just be destroyed. So there we go. We have a custom backend service built from scratch. It's running on our cluster. We can build any image we want using the same general procedure. If you want to clean up this sample, just invoke the delete command on the YAML file, and that will clean everything up. In the next video, we're finally going to tackle adding persistent storage to our cluster. That's all for this video. Thanks for watching. If you like this video and would like to see more, please consider subscribing to my channel.